Now I'd like to introduce Professor David Karoly first. David is an internationally recognised expert on climate change and climate variability, with specialist knowledge in greenhouse gases, stratospheric ozone depletion and interannual climate variations due to El Niño. Many of us have probably heard David talking at various events and in the media, as he played a key role in developing the fourth assessment report of the UN IPCC, the Intergovernmental Panel on Climate Change, which was released in 2007. But his day job is as Professor of Meteorology at the University of Melbourne. He's also an Australian Research Council Federation Fellow. He's chair of Victoria's Climate Change Reference Group and a member of the Wentworth Group of Concerned Scientists and the National Committee on Earth System Science. So, David, climate in 2080.
Thank you very much, and it's a pleasure to be here. And let me start off by essentially giving a brief overview of Ross Garnaut as an independent economist, his assessment of what climate change means for Australia. And he concluded that climate change is a diabolical policy problem, and I'm going to try to describe what is meant by that and the basis for that. But in particular, he said that Australia, as a developed country, has a greater interest in reducing greenhouse gas emissions because the impacts of climate change on Australia are likely to be greater than for any other developed country. And that's because Australia is hotter and drier than any other developed country, and if climate change means increases in temperatures, which it does due to increasing greenhouse gases, then we're going to get hotter. And therefore, small variations in Australia's climate have a bigger impact than any other developed country. And Australia is hotter than any other developed country because we're located at lower latitudes, closer to the equator than any other developed country. The best independent assessment of climate change has been carried out by an independent scientific group set up by the governments of the world. It's called the Intergovernmental Panel on Climate Change. And I'm not going to provide the basis for the conclusions of the Intergovernmental Panel on Climate Change, but an indication of, if you like, its value was awarded jointly with Al Gore the Nobel Peace Prize in 2007. Because I was one of about 1,000 scientists, it means that I share 1/1000th of 1/2 of a Nobel Peace Prize. And none of the funding, which has been allocated by the IPCC for communication about climate change science in developing countries and for scholarships to help developed country scientists to improve their understanding of climate change. So some of the conclusions from the IPCC in its fourth assessment report, and in fact we've already started working on the fifth assessment report, which will not be completed until 2013. The conclusions from the fourth assessment report, which were agreed unanimously by more than 120 representatives, or representatives of 120 governments. First conclusion, warming of the climate system is unequivocal. There is no doubt that over the 20th century the climate system has warmed. Most of that warming over the last 50 years, most of that increase in global average temperature is due to the observed increase in greenhouse gas concentrations in the atmosphere, and that is not absolutely certain. The assessment is that we have greater than 90% confidence, taking into account all uncertainties. That in the future, the best estimate of the warming in global average temperature over the next 100 years is a 4-degree warming, which is 5 times higher than the warming over the 20th century. So the rate of warming will increase in the 21st century. And not only that, but the greenhouse gases that we are emitting into the atmosphere in the 21st century will stay in the atmosphere very likely for most of the next 1,000 years and cause climate change and increases in sea level for the next 1,000 years, no matter what we do in terms of reducing emissions in the 21st century. So what does this mean for Australia? And this graph, I don't expect you, or this picture, I don't expect you to see the text. It shows different regions in Australia which are essentially climate change hotspots. And some of the classical regions that get talked about a lot are in the alpine areas, and there is a very small pointer here. In these alpine areas in southeastern Australia, yes, at high elevations there will still be snow. But the average duration of snow cover in these alpine areas has already decreased significantly over the last 30 years and will continue to decrease over the next 100 years. That will have massive impacts on alpine ecosystems. We have already seen major decreases in water availability in southwestern Australia, which is already having impact on ecosystems in southwestern Australia. The Murray-Darling Basin, let's go back. The Murray-Darling Basin is already experiencing its driest decade, and with substantial reductions in water flow in the Murray-Darling Basin, and there are projected increased or continued ongoing decreases in rainfall in the Murray-Darling Basin. But that doesn't mean that everywhere gets drier. In fact, northern Australia is projected to get wetter. And if we look at northern Australia, the Queensland wet tropics, we expect increases in rainfall in the far north of Australia. And we've seen that in the last summer monsoon season in northern Australia. We also expect major impacts along the Great Barrier Reef, where the increases in temperature and the increases in dissolved carbon dioxide in the oceans cause major impacts on the Great Barrier Reef. And in Kakadu, where the freshwater ecosystems will be greatly affected by inundation from water associated with salt water from sea level rise, we expect major impacts from those intrusions of salt water. So there are many adverse impacts. Let's try to think about now two different scenarios for the future. So let me first talk about scenarios for global temperature change. And the first scenario I'm going to look at is a scenario that says essentially business as usual burning of fossil fuels. And if we look at these different scenarios of greenhouse gas emissions, one is a very high emission scenario, sometimes called the A1FI scenario, which is an acronym that no one remembers, so I describe it as the ExxonMobil scenario. Dig it up and burn it as quickly as possible. The emissions of greenhouse gases in the form of carbon dioxide dramatically increase from 1990 levels of 7,000 million tonnes of carbon to present-day emissions of 10,000 million tonnes of carbon, right up to 25 and 30,000 millions of tonnes of carbon by 2100, even though we're well past peak oil. I'm going to look at another one, this one down here, which is either the rapid transition to alternative energy sources, low carbon, or this one here, which is B2. Under those, we've dramatically reduced global emissions down to below present-day levels, below half of present-day levels of 10,000 million tonnes of carbon per year. Unfortunately, even with those dramatic emission reductions, natural ecosystems can't take up all the human emissions. And the only time we'll stabilise greenhouse gas concentrations in the atmosphere is when human emissions are less than what the natural systems can uptake. And that is roughly 2.5 to 3,000 million tonnes a year. So even on this low emission scenario, greenhouse gas concentrations are more than double pre-industrial and still growing. And under the high emission scenario, we're up at around 950 parts per million of carbon dioxide. The last time that occurred in the atmosphere was 53 million years ago, at a period called the Paleocene-Eocene thermal maximum, when temperatures were dramatically higher than present, and when there was an extinction of marine life that killed 40% of marine life in the world's oceans. Carbon dioxide concentrations now are higher than at any time over the last 800,000 years, and we know that they're due to human emissions. Let's look at temperatures. And here we go. So we've had about 0.8 of a degree warming in global average temperatures over the last 100 years. Let's look at the projections in 2100. The low emission scenario, we have another 2 degrees of warming, which is only 2.5 times the warming. That's the best case. Worst case, about 4 degrees of warming, 5 times the warming in the next 100 years as we've seen in the last 100 years. And the bad news is that independent of the emission scenarios and the emission reductions we make, the warming we see for the next 40 to 50 years, by 2050, is completely independent of the emission scenarios. What does that mean? In the 2020s, there is absolutely no difference in the patterns and magnitude of warming in the 2020s depending on the emission scenarios. We have to reduce emissions to reduce the warming in the future beyond 2050. And so, if we go to a low emission scenario, this one here, at the end of the 21st century, we have warming, but it's dramatically less than this bottom picture, which is the high emission scenario. So the choices we make now determine what happens at the end of the 21st century. We have to make those decisions now, because if we wait till 2050, it will be too late to have an impact on what happens in 2050. Let's look at those different global warming levels in terms of the different impacts on different Australian ecosystems. These bars represent, and the colours represent, the impacts on different aspects of the Australian ecosystems and community. Far left is water security. The numbers here are the global warming amounts. So remember, I talked about 2 degrees of warming at the end of the 21st century versus 4 degrees. 2 degrees has relatively smaller impacts in a range of different aspects, except natural ecosystems and water security will both be substantially affected, even at 2 degrees of warming. But at 4 degrees of warming, throughout all these different systems, there will be very major impacts. We can make a difference depending on which emission scenario we choose. We can also make a difference in terms of rainfall. This is high emission scenario rainfall decreases of the order of 20 to 40%. 40% decreases in southern Australia, in central Australia, 20% decreases. The best estimate for low emissions is much less than that. What does that mean in terms of impacts? This is the business as usual case for a range of different impacts. So let's start at the top. 97% of the Great Barrier Reef will be bleached annually. It will essentially be close to dying, although a number of people have made assessments that there will be possibly some migration southwards. Oops, wrong one. 100% of the ecosystems supporting acacia species in southwest Australia will have migrated southwards. And if you migrate southwards from southwest Australia, you're over the ocean, and acacia species don't grow well over the ocean. 98% of the bowerbird habitat in northern Australia has moved and disappeared. There'll be between a 40 and 96% decrease in long-term snow cover in the Australian Alps, with massive impacts on Australian alpine ecosystems. 86% loss of the freshwater ecosystems in Kakadu. Temperature-related mortality in Australian cities associated with heat waves will lead to between a doubling and a tripling of the death rate for people aged 65 and older. A doubling to quadrupling of extreme fire danger days in southeastern Australia, like we experienced on the 7th of February this year. And as I said, major increases in tropical cyclone rainfall in northern Australia. This is not the worst case. This is just the best estimate for that high emission scenario. Unfortunately, the best case is bad, but it's better than the worst case. We still lose, under the best case, all the ecosystem habitats for the acacia species in southwest and west Australia. But the decreases in rainfall and water supply in the Murray-Darling Basin are substantially less than the worst case. Than that other business as usual case. The impacts on storm surges are dramatically less, And while there are still increases in bushfire days, they're dramatically less. Instead of a doubling to quadrupling, we've only got a 50% increase in extreme fire danger days. So even under massive emission reductions, there are still major adverse impacts from climate change. But the worst case, business as usual, is dramatically worse. So what do we have to do? Well, the UN Framework Convention on Climate Change in 1994 was ratified by Australia, the United States, and almost all countries in the world. 194 countries ratified it. It provided very, very clear guidance on what is needed. And it had an objective of preventing dangerous human interference with the climate system. So its guidance was parties should protect the climate system, and parties are not those things we have on Saturday night, they're the signatories, the government signatories to the agreement. It said we should protect the climate system on the basis of equity. Equity is a hard concept for young children. Unfortunately, it's an even harder concept for governments and political parties. But because of that, the UN Framework Convention provided even more guidance. It said that parties should protect the climate system in accordance with their common but differentiated responsibilities and capabilities. And therefore, developed country parties should take the lead in combating climate change. It didn't say Australia and the United States should wait until India and China reduce their emissions. And it didn't say that because, on the basis of equity, one could say that a fair distribution would be to have each person in the world allowed the same amount of greenhouse gas pollution associated with their activities. And at present, Australia, the United States and Canada have the highest per capita emissions of the major countries in the world. And Australia, United States and Canadian citizens, all of us here, are emitting at typically 5 times the global average. China is roughly the global average, India is roughly half the global average. So what do we need to do if we want to avoid dangerous climate change? Well, of course, the IPCC looked at that. And the IPCC and the United Nations, and the European Union have assessed, as well as the G8 nations at a meeting 6 weeks ago, assessed that the best outcome would be to avoid warming in the global average temperatures of 2 degrees. Remember, 2 degrees was that roughly best case that I talked about. So what do we need to do to avoid 2 degrees of warming? If we want to stabilise at 2 degrees, we need to stabilise at around 450 parts per million, not only of carbon dioxide but other greenhouse gases. So what do we need to do to achieve that in terms of emissions? Well, we come back to this graph. This is the emissions. This is unfortunately emissions now in total carbon dioxide, not just in the mass of carbon. So the units are slightly different. Where are we at present in terms of total carbon dioxide emissions? We're up at around 30,000 million tonnes of carbon dioxide. Where should we be? Well, if we want to be on this avoiding 2 degrees of warming, we have to be at 0 human emissions at some time between 2060 and 2100. In terms of global emissions, we have to have a peak sometime between 5 years ago and 2015, and global emissions have to fall by 50% at least by 2050. What does that mean in terms of Australian emissions? Well, global emissions on average are 5 tonnes per person. Half of that is 2.5 tonnes. What does that mean for Australia, which is currently 25 tonnes? We have to reduce by 90% as the very best case to just stabilise at only 2 degrees of warming. There are a number of key messages from the recent update of climate change science at a meeting in Copenhagen in March 2009. The key message is the last one. Delay in initiating effective action on reducing emission increases the long-term costs, both in terms of mitigation, reducing emissions later, and in terms of adapting to climate change. because both of them will cost more if we wait. So what can we do, all of us? Well, first of all, we can reduce emissions and save money at the same time through energy efficiency. It won't cost us more to improve our energy efficiency and spend less money on electricity or petrol or coal. There are negative cost outcomes that we can take up. We can also reduce emissions by converting rapidly to low and zero carbon energy sources. And those sources exist already through wind power, solar power. And Australia is one of the best countries in the world in terms of sources of these renewable energies. Finally, we can reduce emissions by stopping deforestation. Australia has the largest rates of deforestation of any developed country in the world. There are major benefits to Australian ecosystems also by stopping deforestation and land clearing. We can also increase the uptake of carbon in natural ecosystems and in soils by changing our agricultural practices, and there will be major benefits from changing those agricultural practices and major benefits on ecosystems. Whatever we do, as I said already, there will be major climate change impacts, so we need to adapt to climate change. And the sooner we start that adaptation, the better. One of the big hindrances to acting on climate change, either through adaptation or emissions reduction, are societal attitudes and behaviour. And not just society, but in business, in community groups, and in government. And the improvement in communication and understanding of climate change, both in terms of impacts, adaptation and mitigation, requires the best information to be provided to groups. Scientists, unfortunately, have been singularly unsuccessful in persuading people that the problem is urgent. So we probably need to get the advertising industry on side to persuade people that climate change is a real issue and we need to act now. A group has recently been set up because there have been some problems with climate change scientists as a group getting their message out, and that group is called Climate Scientists Australia. It's an independent group of scientists in Australia. It is seeking a small amount of funding to underwrite its activities independent of government funding, because there have been some issues about government employees communicating climate change science information. And I'm happy to answer questions about that later on. There are things that we can all do, and we can shift from that worst case to the best case scenario in 2080. But we need to act now. Thank you very much.